I was going to say it's a pleasure to be here, but of course I'm only with you virtually. But that's one of the wonders of technology.
Yes.
So I want to talk about the ethics of mathematics in education and society. It's a line of thought I've been working on for 15 years or something. And in a way, it's shocking because most of my life I thought of mathematics as nothing but good. So I'm going to bring out some of the negative aspects and maybe be provocative and controversial in doing so. But this is my argument. First of all, how does ethics enter into mathematics? Ethics is concerned with the good and with human flourishing. And here's 5 elements of mathematics or things that relate to mathematics we could consider. Firstly, the professional ethics of mathematicians, the professional ethics of mathematics teachers, the ethics of mathematical applications, the ethical impact of mathematics on society, including education, and the ethics of pure mathematics. Now, I've put blue crosses to indicate that I'm only going to focus on the last 3 questions. But first of all, coming to the ethics of pure mathematics, in some ways, that's the most controversial thing, because many mathematicians and philosophers would argue that pure mathematics is ethics or value-free. So is mathematics ethics and value-free? Are there no ethical or values within pure mathematics? And the answer depends on the philosophical position you adopt. So let me distinguish 2. One is the objectivist position, that mathematical knowledge is objective, universal, superhuman, and untouched by human values or ethics. And this is a legitimate position, of course, held by many, but we have to acknowledge that it's hard to deny that mathematical concepts, including natural numbers, have been made up by people, and that proof standards change, so they don't depend on timeless fixed logical principles. But people who support this position have their ways of dealing with these problems. Then there is a social constructivist or humanistic position, which says that mathematics is completely and throughout made by human beings, is not there prior to humans being present in the universe. And because it's made by humans, it's self-evident from this position that it's full of values, it's laden with values, including ethics, because it's a human product. In a way, my talk will put a lot of this aside, because by looking at, everyone would agree that the applications of mathematics have an ethical dimension. Mathematics in schooling has an ethical dimension. So the argument about whether pure mathematics is value and ethics free can be left aside. But I'll just point out that there are some ethical elements in pure mathematics that we can identify even without answering this philosophical question or taking sides on this philosophical dilemma. So pure mathematics and the good. And my claim is that pure mathematics embodies aspects of the good, because the way we demonstrate validity in mathematics, public verification through proof and calculation, embodies the ethical values of openness and democracy. That if you're buying something in a market and the calculation of your costs are wrong, you can show with reason in a way that people will accept how the calculation is wrong or how it should be correct. Secondly, mathematics grows through pure research for its own sake and based on the working mathematician's virtuosity. But the growth of knowledge and culture improves human flourishing. So I would argue that's a good in itself as well. But leaving that aside, I'm going to focus more on the ethics of mathematics in education and society. And to talk about the education, the ethics of mathematics is problematic. Mathematics is everywhere in our governance, in our science, information, communication technology. In the modern world, in my lifetime, I've seen mathematics spread throughout virtually everything we do. I mean, if you count digital representation, including all of mobile phone apps, a televisual, internet, everything is based on ways of interpreting the 0 and 1. So, the whole basis of information is now digital, is hence mathematical. So I want to start off by saying, of course, there are good impacts. Mathematics is a great tool that enables the rich material basis for modern life. Almost all people live healthier and more comfortable lives because of mathematics and the science and technology that it supports. But what I want to do is to focus on the negative side, because that's something people haven't thought about so much. Negative impacts, well, I shall go into this more, but there are unethical applications, we can say, and I want to argue about the gross overvaluation of mathematics in our modern society and argue that that's harmful. Now, that's controversial. Some people may think because mathematics supports everything through digital technologies, that it's not overvalued, it's that important. But I shall argue we do overvalue it. Mathematics is overvalued in society, is my claim. And this may be shocking for mathematicians and teachers, but we are insiders. Typically, the people I'm talking to here are not people who come along because they hate mathematics and they want to see it put down. Most of you will be people who love mathematics and use it every day in your work and in your study. So, but that makes us a specialist group, that we're insiders. We're insiders within the mathematics community, and we love mathematics for its precision, its power, its universality. We can apply it to everything: beauty, simplicity, complexity. And I would argue that mathematics rightly claims to be the crowning glory of human knowledge, the crest of the peacock. George Joseph called it in his famous book. And that is actually drawing something from Hindu mythology. I think mathematics is seen as the crest of the peacock in ancient India. But we're insiders. Not everybody shares our love or happy experiences. In fact, we're a very small percentage of the population. And I want to argue that maths is overvalued, and why? Because, as I've said, maths is seen everywhere in a modern computerized society, and that is seen as a reason that everybody needs maths. So the argument is that society depends on maths, so everybody therefore must need maths. But only a tiny group write the apps and the programs that need the abstract, complex, higher level mathematics. All that stuff is going on. When you use your mobile phone and you use the apps on it, you don't have to know. They're a black box. You don't have to understand how its little numbers are being, how the programs are working, etc. It's a good thing if you do, but only a tiny, tiny minority need or do understand it. Another argument is that the lifeblood of modern society is money. Money matters. Money is an application of maths, so therefore maths matters again. Now, but I would argue that everybody needs numeracy. I'm not arguing against that. Everyone needs to understand some number, but not everyone needs high finance. Modern business and government depend on utility, and to calculate utility requires cost-benefit, cost-profit, cost-benefit calculations, which are mathematical applications. But my claim is that only maths insiders do the maths to run society. Maths insiders, this isn't the greatest picture, but I assembled it with what I could find online. So I've got the great crowd of people, 99% more, and then in the middle, a little group which are meant to be the maths insiders. They're a tiny minority. We're part of a tiny minority. So if you look at insider versus outsider views, and I have to be cautious here because really I'm generalizing from my experience in the UK and of America, the Western Anglo world, because I know there are differences that, for example, the belief that some people have an inherited mathematical ability is much more prevalent in the West than in the East. I think, correct me if I'm wrong, where there's a broader notion that if you work hard enough, you'll get it. That it's not, that it's a function of effort more than inheritance. So some of the things I say here may be cultural specific. So to maths insiders on my left column, we see mathematics as a love object. It's fascinating, beautiful, attractive. We see it as meaningful, useful, and powerful. And we all see it as an avenue to personal success. It's what we work with and what gives us our role and our joy. We're invested in it. But for many maths outsiders, and as I said, I'm talking really about the UK public, and you'll have to correct me later if I'm overgeneralizing for other cultures. For a significant minority, the public see mathematics as meaningless, joyless, cold, hard, unforgiving, masculine, rejecting, frightening, and see that the inherited ability of others is not related to their efforts. And I see maths as an obstacle to advancement. So these maths outsiders, a significant minority, fear and avoid it. But I won't deny that, of course, many of the public also love and like maths. So if you look at the actual mathematical needs of mathematics in society, on the left, I'm talking about what the imposed choices and the key. So the bottom of the pyramid is 100% of people, and as you go up, it gets more and more rarefied. So everybody is required to study primary and secondary school maths, and I do agree that to learn numeracy plus functioning for critical citizenship, primary school plus maths, which should be taught to everyone, that is necessary. But when you get to secondary school maths, some further maths for work and study for many professions is important. Well, we could argue, because I have mixed feelings here, because in some sense I do think everyone should study maths to 16, but the problem is for some people it's associated with failure and negative feelings and bad attitudes, and what are we going to do about them? You see, it's only less than 10% who are going to go on to do advanced maths, and 1% who do maths degrees. Maybe it's more, but it's a small percentage. And then to do a mathematical PhD is a tiny, less than 1 in 1,000. So is this whole pyramid designed at filling that top bit? Do we really need to make it compulsory so far up? Well, I'll leave that question to you. But the problem is that there's damage. Some people suffer. Some people don't succeed and suffer. And another answer is we should make the teaching better so that no one leaves school feeling, having negative responses. I also want to argue that if we distinguish the exchange and the use value of mathematics, the exchange value means what mathematical qualifications can get you, from use value, what you can actually do with them, what skills they give you, rather than which doors they let you in. The actual use of mathematics is limited. Everybody needs numeracy plus to be a functioning critical citizen in a democracy, primary school math plus. And although society is mathematized, but most of us use algorithms and in the media, etc., we don't need the technical understanding. It's only a tiny minority need to understand mathematical algorithms and to write them. But mathematics has a symbolic use and exchange value, that getting a mathematical certification, it works as a social filtration. Unless you achieve well, then many avenues are shut off to you. And that's not necessarily because you're going to need the maths. It's just used as a measure of an entry ticket. It's a critical filter. That was a term first introduced in the 70s. So many are forced to study maths against their will, and they lose self-confidence, negative attitudes. So it's damaging for some in education. And I tell you what's amusing is that class in Europe in the 16th to 19th centuries, classics had the same role. If you wanted the good jobs in the clergy or in the military or in all sorts of government, you needed to be good with the classics, Greek and Latin, and the ancient. That was regarded the mark of, those were used as a critical filter. Unless you were proficient in those, unless you passed examination of those, you couldn't get into those top jobs. But I mean, now it looks ridiculous. Those are dead cultures, much of value, dead language, ancient Greek, and modern Greek is different. Latin, of course, is not spoken by anyone. So to make those necessary, their role, their symbolic role as a critical filter is so evident. But it's switched over to mathematics, which has more use, but nonetheless, it's valued beyond its uses, I'm arguing. And maths tests are a critical filter. Students of maths have to go along the tightrope, or to pass their maths test, to achieve success at maths. And if you have overall success, you have improved life chances. But it's a critical filter, and people fall through, people go down, people are eaten up by the crocodile. It's, what about those who are harmed or hurt by it? Maths, and maybe this is controversial, but there's a lot of research that shows there's a strong correlation between results, educational results, and particularly maths results, and the kind of jobs and positions you get in society. So I'm arguing that mathematics assessment works as a fractional distillation system, where children are fed into this system, and after these years, you get the lower attainers, unemployed, underclass, slightly higher attainers, unskilled workers, and they may not last through to the end of education. And then you get your skilled workers and your professionals. And of course, the rewards are proportional to that ladder. Math success is highly correlated with career outcomes. And success at maths alone should not be the key arbiter of life chances, I'm saying. That, obviously you need a certain amount of mathematics, but mathematics has because of its exchange value, it gets you further than you're actually going to need. You're not going to need it necessarily in the fullest extent. So one of the social costs of forcing people through mathematics is negative attitudes. And I've assembled some pictures here. Many learners and adults are labeled as math failures. And again, I'm talking about England and the USA. They lack confidence, they fear mathematics, they have reduced opportunities. This strange thing in the middle was about how primary teacher training recruits admitted that they had maths terror as children themselves. It's slightly exaggerated, but there is fear. So this is some incidental damage. And I'm saying that we as maths insiders are complicit in overvaluing our mathematics. We gain more resources, but does everyone need to study maths so far, so much? We don't make all these other subjects like psychology or computing or arts or philosophy. We don't force people to study those, but aren't they equally important, or for some people? And so I'm asking the question, is maths failure the learner fault or society's fault? So there's hidden harm caused in education, overvaluing qualifications, pressure to rush through the courses without fully understanding, high-stakes testing. All these cause negative attitude to maths. It's unplanned damage, but we must recognize it, that we are harming some people, even when we mean to do good. In medicine, they say, they have the principle of first do no harm, that they're beneficent, try and do good, but also make sure you're not doing harm. In education, we think we're doing good, but we're not attending enough, perhaps, to some incidental harm we might also be causing. So that's my critique of education, or one part of my critique of education. But going on more broadly to the ethical problems of mathematics in society, leaving education aside, I've listed 4 different types of applications of maths in society. And I'm not saying this is all there is, it's just one way of conceptualizing it. First of all, there's math washing, using maths to deceive, to conceal, to persuade. Secondly, there are directly harmful applications. They may benefit some, but do some harm. Then there are performative applications that change social policies, often by, you may not even know that you're doing that. And then lastly, if you're successful at maths, it can lead to amoral instrumental thinking when you apply it beyond mathematics, treating people as objects. So these are 4 dimensions I want to distinguish of critique. So math washing, we know about how statistics can mislead. For example, those columns, although it looks like the full price sales are much bigger than the reduced price sales of the newspapers, that column looks more than twice as much. When in fact, if you hadn't cut it off, it would only be the lower one is 92% of the higher one. So by messing with your columns and your labeling of the columns, you can make an impact that exaggerates differences. That's a very simple one. We know about that and show that in school. This was something in Britain during the COVID, when the Prime Minister came up with this equation. He says, we have an equation upon which we base our COVID alert level. It's what the COVID alert level equals R, the rate of inflation, plus N, the number of infections. And I saw that, I thought, yeah. And then I came back and thought about, that's not an equation. That's rubbish. If it was a rate, you'd multiply it. You wouldn't add it. Anyway, the COVID alert levels are 5 different discrete levels. You can't get that out of an equation, which would give you a continuous quantity. This was just designed to make the government decisions look scientific and to give a kind of scientific background. And all governments do this. I'm not particularly criticizing this government, although I'd be quite happy to do so. But, it's something that's used, math washing. Use the certainty of mathematics to try and slip something through. I'm not saying their policies were wrong. It's just I thought this was a deceptive piece of argument. I couldn't resist math washing and hand washing. Hand sanitizers, we're told, kill 99% of germs, 99.99% of germs. And then you see the little footnote, the small print, under laboratory conditions only, when in the real world, they kill as few as 46%. So the headline exaggerates math washing. Say it in numbers and it looks really good. So my second category is harmful applications of mathematics. There are algorithms designed to fake results. There was that scandal with the Volkswagen and other car companies. They had apps and programs within them so that they only when they were to find out when they were being tested and improve the results to fake the scores. So that was pretty bad, and it was a stupid policy too, because they ended up having to pay out tens of billions in compensation, which was a lot more they cost them than what they gained by cheating. So another example was the Cambridge Analytica using Facebook data to try and influence politics in America and the UK. Again, it was illegal, although I don't think anyone's been prosecuted. So these are harmful applications. And also, this is an American program that to predict the risk of reoffending. And these two people, it predicted the girl, Brisha Borden, as being high risk and gave her a score of 8 out of 10 for risk. And this guy, Vernon Prater, got a low risk rating of 3. But he was a career criminal and she'd just stolen a bike. So this program, which it wasn't intending to do harm, but because she came from a black neighborhood, it assigned great, negative weighting to it. And although she was just a juvenile delinquent who reformed, and he was a career criminal, it said it predicted she would do worse. So here we have again, it's an unintended but harmful application. There's the surveillance threat from surveillance states and surveillance capitalism. Many countries are imposing surveillance where they try and control their citizens, and capitalist corporations are trying to spy and manipulate and control us as well. Now, obviously, they want to know their market, but there should be strong legal constraints on what they can do with information about us. I'm just pointing out this is another area of potential abuse and actual abuse. Misuse through algorithms. Something that's less remarked is that mathematics is performative, that mathematics it's not just a mirror or a camera. When you have a model of something, it doesn't just show you what that reality is. It actually is an engine. It changes what it's describing. So, for example, when schooling becomes about passing exams and it's all focused on scores, then you are not learning flexible and adaptable skills as much as you are learning to pass exams. In other words, the exam system is changing the nature of schooling. We know that in education, the tail wags the dog, the tail of examinations wags the dog of curriculum. When business is all about profit, only about profit, the valuable services become secondary to profit. When health or welfare are just about meeting targets, professionals have to focus more on meeting the targets and gaming the system than doing necessarily what they want to do, what's good. Donald Mackenzie is a great student of mathematics and society from the Edinburgh School, and he wrote this book, An Engine, Not a Camera, how financial models shape markets. In other words, how mathematics reshapes the market. And he describes the formula that killed Wall Street. It triggered off an automatic computer sell-off of securities through an app that was meant to be protective, but it ended up triggering the mass sell-off, causing the 2008 7-8 market crash. In other words, it shaped the financial market. It wasn't just enabling, it actually caused a bad thing to happen. It was performative in that sense. So in the performativity of maths apps and systems, broader concepts of value are replaced by mathematical measures, which may be questionable. Success is not judged by meeting the targets. It's judged by meeting targets, not just by the good done. And this inevitably, I claim, degrades quality of service. And there's a law here that says that. Oh, going back in history, how Victorian payment by results in British schools degraded the system. Teachers were paid according to the number of students they had, the number of pupils, and their test results. But in reality, the teachers encouraged cheating, drilled their pupils mercilessly on test items, falsified enrollment registers. Because their pay was performance-based, it ended up changing the nature of education. That was then, but such things still can happen. Now, moving on to my last of the four types of damage, which is the instrumentalism. First of all, let me say that the mathematical way of seeing the world, where we replace the beautiful complexity of nature and the human worlds with simplified models, it's a wonderful and powerful thing. It's not necessarily a bad thing. In some sense, it's a wonderful, joyous thing that we can look out, and when we look at the apple fall from the tree, we can think of Newton's law of gravitation expressed mathematically, or so many things. But it's not the same as the world. And what I'm arguing is that the mathematical way of thinking leads to certain kinds of styles of thinking. We're certainly with algebra, we detach meaning, we follow rules precisely, we reduce complex situations to simple things that we can calculate, simple numerical models. We engage in ethics-free technical reasoning, and we reason with separated values. We value rules, abstraction, objectification, reason, dispassionate analysis, impersonality. Carol Gilligan distinguished these. She called them separated values. And within mathematics, all this thinking is valuable, and it's part of maths. But my claim is this, that by making people study maths, and those who are successful at maths especially, when we apply that to social problems, this can be difficult. So if we instill the mathematical way of thinking, it instills a simplistic epistemology where everything is true or false. Thinking in ethics-free and value-free ways leads to ethical desensitization, diminishment of responsibility. It trains instrumental reasoning, where we focus on the means and not the ends or values of what we're doing. So separated values beyond mathematics imply that actions bear no ethical or social responsibility. People have talked about corporations as psychopathic, that, they have to, their role is to make a profit no matter what the harm they do. And it's the role of government to control that. There's no problem there unless government failed to do that. The trouble is, with this mathematical way of thinking, everything's right or wrong. And I like this picture of the man thinking in simple right or wrong. We can't apply that to everything in life. So we have the dangers of instrumental reasoning. And that if we start looking at persons, animals, and the environment and treat it as objects and mere resources and not as intrinsically valuable things, you get the destruction of the environment. You get forms of labor and manipulation of people that really don't respect their human dignity. People treat it as objects. So I'm saying that mathematics, by encouraging those ways of solving mathematical problems, if you don't realize that the world is more complex and you need to bring values and empathy in there, then that mathematical way of thinking can be damaging when applied outside of mathematics. So all in all, I've said that math and its applications has two faces. There's the familiar good face. I've stressed the other, but we know the benefit and value personally, socially, intrinsically. Mathematics has got wonderful benefits. But what we don't perhaps discuss enough is the bad face, that education, mathematics is overvalued. It leads to social reproduction. It leads to negative attitudes and negative image for some. And in society, we have these four harms I've listed: math washing, harmful applications, performative applications, and instrumental thinking. And those are not intrinsic, but we need to be very much on our guard against those. So how can we prevent or correct these things? I was just checking the time to see if but I haven't even used up my 45 minutes, so that's good. How can we correct or prevent such harm? Well, I think through education. Of course, we need to regulate everything else in society, but I think it starts with education. And I think we should include the philosophy of mathematics in the mathematics we teach. I don't mean teaching about absolutism or social constructivism or Platonism or logicism, but I mean teaching the limits of mathematical knowledge, that its certainties do not always apply to the world. There's always a margin of error. I remember working with primary school teachers, we had measuring strips like they use in sewing and making clothes, 1 meter long strips, and I held them all up together, and there was 3 centimeters difference between the shortest and the longest, and we were all shocked because as mathematicians we thought a meter is a meter, and a measure of a meter would be a measure of a meter. But there was a margin of error of 3% between these different measuring instruments. As mathematicians, we don't realize the world is not so exact. We need to be teaching that in school, that things are not just true and false, that solutions don't just have one problem. And that's our fault in a way too, if we keep giving tasks to our students where there's only one right answer. We need to also have questions where there's judgment involved, where you optimize, you look at different variables and things. I also think we need to add the ethics of mathematics to mathematics courses. And I don't mean have a little separate thing where we talk about ethics and what's good and what's bad, but I think, we could teach the limits and dangers of instrumental thinking, maybe to older students, but also by showing more applied examples, more, where they have to take ethical and other value dimensions into account. So using real world examples like COVID or global warming, pollution, environment, all the kind of, that first of all, it makes mathematics more lively when you use problems that reflect the world, or hobbies, or all sorts of things, sports, make a better link with the world. I think we also need to reform mathematics teaching, where we don't stress exams and testing so much, because that leads to test anxiety. We give students choices. We humanize math teaching. We acknowledge our duty of care, that we have to be attending to their maths attitudes and images as well as their success at mathematical tasks. Another thing I think is very important is not to demonize errors. That, you know, if you make a mistake, that's to be expected. Mistakes are inevitable when you're learning. They're not sins or failures. Students shouldn't be ashamed to make mistakes. We all have to make mistakes to learn. And also, I think we need to teach critical thinking, how to use our mathematics to look at social and business applications and the claims in the media, so that to avoid some of the dangers that I pointed out. And, you know, another thing to do is to add mathematical appreciation for only a small part of the curriculum, as well as mathematical capability. Maths is more than just calculating, solving, and proving. We should make links that show maths in art and culture and how it links, the impact of applications in maths and society in the context. That brings in some ethical dimensions, looking a bit at the history of maths and maths and history, proof and how maths is validated. I've already said that. Controversies even in the philosophy of maths, where, you know, a lot of people think maths is the least controversial subject. I think students should realize that maths, like poetry, is full of big, exciting ideas: pattern, modeling, symmetry, structure, equivalence, invariance, proof, paradox, recursion, randomness, chaos, infinity. I could add zero. You know, add what your favorite concepts. I think we should be including critical citizenship in our teaching, so that students can actually see for themselves some of these bad applications, be able to control their own lives better. And of course, the ethics of mathematics as well as part of the appreciation. So there's a lot to critical citizenship, looking at how maths is used in society, understanding the limits of validity, seeing, and I think every citizen needs these critical citizenship capabilities to defend democracy and the human values of good civilized societies. And I was talking about the surveillance state and surveillance capitalism, which I have in my middle triangle. But mathematics specialists are only one part of that, because there's also the business and corporations, there's also the state and the government who contribute to that. But those people, the business and the politicians, all come through our schools. Don't forget that. We have our hands on them. We're shaping their thinking. So if we can teach mathematics to see mathematics and its applications more ethically, perhaps we can be shaping the thinking of those other people who contribute to these things in society. See mathematics, bring in ethical considerations thinking about mathematics. Maybe teach all citizens to see mathematics as having ethical dimensions. And then we may be able to curb the excesses of surveillance capitalism, surveillance state, politics manipulated by data and applications. That's it. I'm on time. These are just some publications.
Go ahead. Thank you so much, Paul. This is the time for questions, and Paul is ready to answer any burning question you might have about any of the ideas he mentioned. So please feel free to speak or even type your questions in the chat box. Yes, Bill. Hello, Bill. Go ahead.
Paul.
Hello. Oh, hi, Bill.
Great to see you again.
Great to see you.
That the Filipino audience had a chance to finally meet you, even though electronically. Thank you for your talk. I arrived a little bit late. My apologies. So I missed the structure of your talk. I'm interested in that one word that you had included in your presentation, the intrinsic goodness of mathematics. And I'm puzzled a little bit. Is that admitting that mathematics is intrinsically good, but it's the way it is applied that can be good or bad? Are we differentiating between mathematics and mathematics as a practice?
Well, and in a sense, you've put your finger on a contradiction that I'm still grappling with, because I think there are intrinsic goods within mathematics, but that doesn't mean that pure mathematics is wholly intrinsically good. Currently, I'm thinking about how, because my view is that mathematics is not necessary. It's something that's been installed to serve certain interests, typically commercial interests in the first instance. In the ancient civilizations, number counting, not number, but the written calculations were invented primarily for bookkeeping, for trade, for taxes, for tribute by big states. In other words, it was about controlling resources, controlling the world. And, there are certain indigenous groups who refuse mathematics and say, for us, it's rude to ask to be always counting everything and always looking at quantities and always measuring, especially when it comes to people. If you're doing that, that's a degrading thing. So there is a sense in which the very assumptions of mathematics have a certain are based on values about an approach to the world that is trying to manipulate, control it, and primarily for the benefit of elites. But on the other hand, it's taken on a life of its own. And so I was saying earlier that mathematics is an element of culture, that yes, it may have those roots, but it also has other functions that mathematicians developing their virtuosity, proving new theorems, adding to the sum of human knowledge, that is a good. So it's got these two sides in a way, and that on the one hand, there are intrinsic goods in mathematics. I also argued that it's democratic in the sense that you can always, a calculation can be discussed in public, and the public has a voice on whether a calculation is correct, that you have to display your proof or calculation. Admittedly, the proof will only be comprehensible to a minority, but a calculation is comprehensible to anyone who's studied mathematics at primary school, and so they can see if the bill is correct or not. So there's a democratic element to it and an openness. So it has all the, so the idea that mathematics is Janus-like, both pure and applied mathematics, that there are problematic aspects as well as beneficial aspects, I think I would argue throughout. So when I say intrinsic, I mean that they're built in, but that doesn't mean that they're the only thing in there. Is that, I'm trying to grapple with my own contradiction.
Yes, yes. If we look at that democratic nature of mathematics, is it a nature of mathematics, or is it a practice that can be non-practiced sometimes? Mathematics can be
undemocratic. Yes,
yeah.
Of course it can be, and it can be used to conceal things, but there is an element of mathematics. I mean, because for me, the purpose of calculation and proof is to display how you arrived at an answer. I don't accept that answer is right or wrong, whether you have a correct calculation or proof. I think those calculation and proof confer the status of acceptability, and that involves a social acceptance from my perspective, and therefore those are intrinsic. So it has those elements of intrinsic elements of openness and democracy in part, but it can be used, I know that Heurup, who wrote a lot about ancient civilizations, he argued it can also be used in a way it's part of justice, but it can also be used to conceal injustice. And we know that when people show you a calculation or a formula, they've already chosen what they're going to compute, and and you can challenge the calculation, but if they've already assigned values to things, numerical or other values, then they've set the game up, and then you're stuck within it. So sometimes those hidden decisions about what aspects that we're going to validate can conceal. But I think they're both there. I don't know if you do you think I've made my case, or are you doubtful?
What I'm worried about is a statement I hear very often, that mathematics is neither good or bad. It's how you apply it. So it's as if there is something called mathematics that is not a social practice. And that's what I'm trying to
Okay.
wrestle
And I
with.
share that. Yeah, I share that view. But carry on. Sorry.
Yeah, that's it. That's my worry. By looking at something called intrinsic good in mathematics, there are good things in the practices of mathematics, but I'm not sure what is that thing that is intrinsic to mathematics, without which there is no mathematics.
So your worry is that I'm slipping back into an objectivist, absolutist.
Or your listeners would.
But and I agree that one of the problems is to convince people that mathematics has values. And in a way, I use the good within pure mathematics as a way of sneaking some values in and say, look, even mathematics in the purest sense, we can argue has values within it. Let's start on the good ones. Because can you argue that, could you have a pure mathematics without calculation and proof? And maybe you could, and then we'd have to look at what was intrinsic to those different practices. But so when I say intrinsic, I mean built into the way it's practiced, I suppose. Although I have to say, it's hard for me to completely cast out of my thinking that old objectivist views of mathematics as something that transcends humanity, even though I've spent my life arguing against that. It sneaks back in somehow. But then you see, I believe that cultural objects are real. Mathematics is a cultural object. Cultural objects are real, and they have real impacts. So even pure mathematics is a real thing. But the question is its nature forced on us by nature? Does it have a nature, or is it something that's humanly constructed? And I certainly cleave to the second view.
Thank you.
But these are ongoing debates, and I struggle. And currently, I'm writing about necessity compulsion within mathematics, and how that mathematics, more than any other subject, has necessity and compulsion written into it. Schooling is all about degrees of compulsion, the task, but mathematics itself, although you can choose at a higher level which rules you apply, those rules have a certain way of doing them. And in school, of course, there are certain things you have to do to get the right answer. There's quite a lot of compulsion.
Thank you.
Thanks, Bill. Paul, there are some questions that have been entered in the chat box. May I just read these questions and you can respond?
Sure. I've actually managed to get the chat up, so because I was saying, so I got it as a side. But please, you tell me. Yeah, go ahead.
There's a question from Dr. David Roden. How do you know if an author is being sincere about the position he or she is presenting in a paper, rather than just playing tricks on the editors, such as what Alan Sokol did to the editors of social texts?
Right. That's a really tricky question, isn't it? And if you're now, that Sokol hoax, as it's called, where a paper was submitted to a journal on cultural studies, to decide if the paper is valuable and is making worthwhile points, that is up to the judgment of referees and editors, experts, isn't it? And sometimes you can trick experts, and that's what happened in that case. These very clever people decided they wanted to show up postmodernism and wrote a paper that made a lot of claims using mathematical scientific concepts in a strange philosophical way, and got it published. And so that was a hoax. Wow. Now, I think their point was that this is a field where you don't know what's right or wrong, what's true or false. Anyone's opinion counts. But you see, whereas in mathematics and science, you have definite tests for truth or falsity. I think I'm arguing against it. I'm saying that there's quite a strong consensus in mathematics about what's right or wrong, that if you submit a mathematical paper to a journal and experts look at it, there's quite a strong consensus about what is correct or what is an acceptable proof. But because it's all humanly done, it's never for certain. So when what's his name? The guy who did Fermat's last theorem, Andrew Wiles. When Andrew Wiles first published his proof of on Fermat's last theorem, so called, it was accepted, but there was a mistake in it, which was pointed out. And supposing no one had ever pointed that out, then you would have a flawed paper that had been published. It wasn't a trick, but it was a mistake. And but the self-correcting mechanism of publication, journals, refereeing, and people reading critically, critical thinking, which I'm endorsing, means that it was spotted. And then, of course, Andrew Wiles worked for 9 months, corrected the error, and it's accepted that he ended up with a acceptable proof. So I suppose there's a difference between sincerity and mistake, that you could publish something with a mistake in it, and you could publish something where you're trying to fool people. Interestingly enough, that's one of my complaints about mathematics. It can be used to try and fool people, especially when there's commercial gain involved. But the answer is, you just have to, if you want to try and determine whether a paper, whether it's mathematical or philosophical or cultural, you can't determine whether they're faking or not, but you can determine to the best of your knowledge and those of your referees that whether it stands up and whether it's acceptable. And it's never foolproof. People are very clever. Fakery, it doesn't usually go on so much in the intellectual sphere, but we know that there are problems with, for example, pharmacological industry, where they pay to have distorted results. The real problem for fakery is on the internet, with scamming people of their money, etc. But I think we just have to be on our guard. We can assume in academia that people the best intentions, but we have to look carefully and scrutinize. So in other words, there's no ultimate touchstone that will guarantee that a paper is correct and sincere. You have to go by the best of human judgment.
Thank you for that. Another question from Dr. Levi Elipane. In the Philippines, we have a lot of auditing, accreditation for quality of or in universities. It takes so much work and could define rankings, fundings of universities. What can you say about that?
Well, first of all, I mean, this is part of a whole climate that came from, I don't know if it came from business, about trying to measure their total quality management and assigning measures to everything. And sadly, now that has been applied. And this is part of my critique. When you apply measures to things, you change them. So I've lived through that myself in the university. I remember I was led the master's and doctoral programs in maths education, and we were being visited by the QAA. It's some kind of a national accrediting thing. So we spent a month collecting all this paperwork, a room we filled with paperwork, or justifying everything, getting lots of feedback. And it was enlightening in a way. We did get nice things back from students and made sure we had all our documentation in order, all the programs were specified. And then the people came for 2 or 3 days, sampled it, and gave us a top ranking. We were lucky. We thought we were really special. But after that, they seemed to give everyone top ranking. So, and I remember feeling pretty destroyed at the end of that solid month of working from morning until midnight, getting all that paperwork ready, and feeling a bit discouraged that was it really worth it? Yes, you need accountability, but when the assessment regime is so tough and so demanding that it distorts your work, then you have to ask, is it worth it? So this is part of what I'm critiquing: the ranking of schools, the ranking of universities, international comparison tests, all those kind of things. The trouble is that they force institutions to focus on the things that get you the marks rather than the things you think are intrinsically valuable in education. So in other words, those assessments are performative. They're changing what you do to jump through the hoops. So I think that's unethical. I think it's problematic. I can't tell you a way of resisting it, because unfortunately the powers that be are very, very big. It's an international fashion, isn't it, that universities want to have the top ranking, even if it's only, as in Britain, there are newspapers that do rankings of universities, and they add lots of silly things together, like the percentage of students who got a job within a year. Yes, that's valuable. The number of highly cited publications in some measure, the grant money obtained, and then they have about 10 different dimensions, and they add them all together. And then where you come in that gives you, but we do the same with IQ scores. The British IQ test has 23 dimensions, including digital memory and various geometric things, and how many of those things you can do right in a certain time. 23 different dimensions, quite comprehensive. Then they add it all up, and that's your IQ. And you think, well, that's not the same as intelligence. That's the same as performing. Now, of course, they've done IQ, a lot of psychometrics, make sure that they're reliable. In other words, they take out questions that don't sit, on test retest basis. They fluctuate. But I would argue maybe it's not so valid. Is that what we mean by intelligence? It's just a device for sorting people for some purpose. It's not really what intelligence is, your IQ score on some test or other. So there is this problem with devising scores for everything, measuring everything, and then making your judgment based on those measures. This is what I call performativity, that you end up jumping through the hoops instead of doing what you think is best. Now, of course, IQ tests are useful because you can tell. I remember my daughter, when she was 6 or 7, they said, well, we're not sure if your daughter is really, really bright or out to lunch. And so they gave her an IQ test, and they decided she's really, really bright, because she was asking questions and things. That's a silly story in a way, but the point is they can be a useful tool, but they're not the whole story. Is that an answer, I hope?
Yes, I think so. There's another one from Dan Kennedy, Hipona. What do you think of combining applied mathematics and pure mathematics as an undergraduate degree, and just have a wide variety of specializations rather than having them separate?
I mean, it makes a lot of sense. I say that through gritted teeth because I studied pure mathematics and mathematical logic, and I never did applied mathematics, and I didn't like the look of it. And even when I taught statistics to undergraduates, I didn't really like it. It just seemed kind of irrational ragbag of recipes, whereas probability was all right. But nonetheless, maybe if I'd been introduced better to applied mathematics, but you see, at school, I did only pure mathematics, so I never did Newton's laws of motion and those kind of things. I did them in physics, but not in mathematics. So I'd never done mechanics and statics and those kind of things. And I can see the beauty of that analytic framework. So maybe it's just that I'm lacking in my own personal education. And if you want to see the ethics of mathematics, if you want to have more ethics within mathematics, I think having applied mathematics is necessary, and looking at the strengths and weaknesses of different applications of modeling. So I can see the logic in it. I think it's a matter of balancing choice. I mean, for example, the university I first went to, University of Sussex, was a new university, and they decided they want everyone to do a bit of science if they're doing arts, or a bit of arts if they're doing science. And the idea was to try and balance you a bit. So maybe it should be that if you're going down the pure maths route, you should do some applied maths as well to broaden out your education, and vice versa.
Okay, great. Another one. Regarding the use of maths ability as a critical filter. This is from Dr. Mark Tolentino. Is there a role for the attitudes and mental processes, such as problem solving, precision, rigor, developed by students in learning higher mathematics?
And first of all, and I don't want to be critical, but I wouldn't say it's the use of mathematical ability as a critical filter. It's the use of mathematical achievement. And ability and achievement are not the same thing. We presume we can generalize about ability based on achievement, but quite often people don't display their true or potential abilities for various reasons. Maybe the mode of testing, the opportunity, the time, their own attitudes, etc. So I wouldn't say we're using mathematical ability as a critical filter, but a proxy for it, namely mathematical achievement. And there are problems with identifying potential mathematical ability with that. Is there a role for attitudes and mental process? Well, it's very hard to test mental processes, and but on the other hand, I think if we had extended assessments, which include more extended pieces of work, where you were problem solving, you were engaging in investigations, when you were using a broader range of processes, and that was, and you got credit for that, then I think that would be a more valid form of assessment. We had this in Britain after the Cockcroft report of 1982, which recommended problem solving and investigations, as well as practical work, reinforcement and practice of skills, exposition, and the whole panoply of mathematics approaches. There was an attempt to introduce in the new exam what they called investigations as tasks for assessment. Now, what they called investigations were actually guided discovery. That an investigation really should involve you choosing your topic, choosing how to explore it. That's not so easy in a timed examination. So what they called investigations were guided discoveries, where they gave you a situation, and then there were a series of questions that encouraged you to generalize and explore different ways of taking it. Of course, you could have a broader, if you include extended pieces of work or projects, then you can explore a broader range of mental process or functioning of mental processes as the assessment rather than just a test. But of course, that does introduce other problems, like, for example, if you're doing an extended piece of work, will you be getting parental help? Do you come from a wealthier background where you have more resources? And I suppose you could do the extended pieces of work in a classroom. In other words, it raises other issues. And the reason that it's not been a principal reason that that's not been taken so far is usually because it's just cheaper to give a test with simple items or slightly more complex problems to solve. But I like the drift of the question, because if you were testing more fully what people could do, and maybe even group work, if you're testing more fully, then it would be a more valid assessment of mathematical ability rather than just a limited domain of achievement.
Thank you. Another one. Are you okay, Paul?
Yeah.
We have lots more.
I'm all yours.
The original intent of pure mathematics, this is from Patrick Lawson, is to solve problems within the field of mathematics, typically independent from other sciences. However, given how pure mathematics may eventually find real-world applications, such as how number theory led to the development of cryptography, in what ways would you view pure mathematics being used for evil?
Well, pure mathematics. Let's get this straight. Historically, we had applied mathematics first. We had social situations that needed mathematizing, and it was out of the development of the calculation and teaching scribes in the ancient civilizations that you got certain people who became teachers and perfected their calculation techniques. And I think that's the beginning of pure mathematics, where you start doing it for its own sake, to develop your own virtuosity. But we must never forget that that's how mathematics started, and that many, many centuries later, when we look at, say, for example, French people with money who could do mathematics on a Sunday, like, or maybe were in the clergy, like Mersenne, or people like Pascal, or Descartes. Of course, he was employed as a soldier and a tutor and things, and they did mathematics in their spare time, and some of it was pure. First of all, they sat on that tradition, but it's because mathematics is indeterminate and has so many applications. Pure mathematics, it can be viewed as something that's value free, but because it comes out of human activity, any human activity has values in it, and obviously there are beauty is a value, and pure mathematicians strive towards beautiful results, elegant results, internal values, if you like. So I would argue that as I was saying to Bill earlier, Bill Atway, that even the purest of pure mathematics is still a human activity, and hence, like other human activities, is infused with the desires, interests, values of its makers.
Okay, thank you. More? Are there ways to continually assess a primary or secondary student's grasp of a math topic other than competency exams or standardized tests? How can a teacher effectively track individual students' personal growth in mathematics within the surprisingly short span of a semester?
Well, this is a technical problem in the sense of how can you do this, and the answer is it's difficult. That unless you have smaller classes and tighter teacher-student relationships, you can't devote so much time to them. I mean, of course, all of teaching is a process of continuous and formative assessment. You're setting tasks and you're keeping a note how students do on it. You may, as well as tests, there are all the other activities they do, and you can keep records of them, books of their activities. You get a sense of where they're going, and I guess you can, talk to them individually now and then, but it is tricky. But I mean, formative assessment is very important, because you need to see where they need correction, where they need guidance, where they need help, where they need extra work. And I hate to say it, but computerized instruction can actually help in some of these ways. As an adjunct to, I only say I hate to, because I think the teacher plays an essential role. There's that human contact, but you can use I've seen tutoring systems that could help children with certain areas that they, so it's a tricky question. The answer is you need more time, really. But certainly the techniques exist for formative assessment, and someone like Dylan William, who writes about assessment for learning, and has argued that a formative assessment, feedback to children, is actually one of the greatest enhancers of their overall achievement. That if you can do that systematically, but how you do it is tricky. I mean, because it takes time and resources.
Yes. Yes, we do have those problems in conducting formative assessments in our classes. Bill, you have another question related, or
I noticed that we do have a little bit more time, and I have many comments. I really enjoyed the examples that you gave, and I think it was very illuminating and comprehensive lecture here. In my thinking, this is probably more a comment than a question. In my thinking of commitment to ethical performance and behavior, I'm also committed to questions of equity. And the two combined implies to me that the question of good and bad is not a general question for society, but specific question, good for who and bad for who. Even the mathematics that led to nuclear weapons and so on, some people might argue it is good because it reduced wars in some situations, but obviously other people lost their lives from that. Something can be talked about the technology or the mathematics that leads to increased profits of companies, led to maybe exploitation of labor and increased prices on the general public. So there is always a question of good for who and bad who. That complicates the discussion a lot.
Yes, I pondered about the relationship between ethics and social justice, because ethics sounds more personal, although you can apply it to, but you know, when you apply it to society, then as you say, then the question is not just what is something good, but is it good for who? Who gains, who loses, who profits? Social justice is not the same value, but it is underpinned by. And it's interesting because I've been looking at medical ethics, where I mentioned two dimensions of medical ethics. One is beneficence, trying to do good. One is non-maleficence, not doing harm. Another one is autonomy, trying to respect the individual that you're working with. And the third one is social justice, making sure that the benefits are spread equally insofar as you can, or having the ideal of the benefits being spread equally. So I find that quite useful. The obviously medicine has developed its ethics much more than mathematics have, starting with Hippocrates back in ancient times, the Hippocratic Oath. So ethics and social justice overlap and interact, but they're not identical. And I'd love to see. I had thought of trying to write something on that, which I haven't, or encourage someone else to write on that, which I haven't succeeded. And maybe I'm ignorant of people who've explored that more fully. I'm always being amazed at the wonderful stuff that's out there. Only recently have I found the sociology of calculation, which looks at the role of calculations in shaping society. That it's a whole branch of sociology, which, although I'd heard a little bit about 10 years ago, from suddenly they cited something I'd done as one tiny little bit in a big mosaic, which is how I think I found the link. And excuse me. So yes, it's a very interesting area.
Thank you.
Catherine, you're muted.
Harvey Felipe asks these questions. Is the problem in all math curriculums all over the world, or are there good examples of a functional math curriculum that places an emphasis on ethics? Do you know of any?
That's a really good question. And, I always, for me, the Scandinavian countries are always good. But then I used to be a visiting professor in Norway at several institutions. But the irony was, for example, we like a more democratic, open style of teaching. child-centered teaching we regard as a value that we hadn't attained in Britain. But one of my colleagues in Norway said, yes, in Norway we attained that, and we did it to excess, so that everything's about the child, and they've lost the subject. Now I don't know how accurate that is, because they're usually pretty good on what they're doing. The answer is I can't really give you a whole country example. I can't really say that. I mean, I'm aware of the deficiencies in my own country, Great Britain, but there's still a lot of good stuff happening here, with different people, different schools, teacher trainers, groups of teachers working together to develop a more just curriculum. But I can't actually point to something that's as an ideal example, a country. I'm sorry. I'd love to know if there are really good places.
All right. Yeah, certainly. It will be very difficult to find a country that offers an ideal curriculum. Another comment from Dr. Levy. Right now, evidence-based education is very popular. Hence, evidences measure professional knowledge. Is this ethical all in all? What could be an alternative?
So is that professional knowledge of teachers? Was
Yes.
that? Yeah.
I would think so, yes.
Well, it's an interesting issue, isn't it? I mean, I have worked with both primary training, or educating primary as well as secondary teachers, and tertiary college teachers. And I know for some primary school teachers, they had struggling to pass their maths, and they left, and they ended up just scraping through and not having a good feeling about mathematics. And yet they were going to have to teach mathematics to their classes because they taught all subjects. So that's more attitudinal than knowledge-based. But I did find in my research on that actually teachers could have different sets of attitudes. They could have different identities in a way. They could have a notion of themselves as a math learner and the notion of themselves as a math teacher. And the fact that they had some weaknesses in their notion of themselves as a math learner didn't necessarily mean they couldn't be confident in them as being a math teacher. So they could be separate things. Obviously, you need knowledge to teach. But it's necessary, but not sufficient. We know that, I think. So just qualifying teachers by the level of mathematics they've done, I don't think is enough. And of course, we know ever since Lee Schulman, etc., who particularly popularized this, the notion of mathematical knowledge for teaching, or whatever you call that professional knowledge, which is something different. All the ways you can represent knowledge. All the kind of activities and all the experience you've had in classrooms working with kids. And of course, I suppose university lecturers will have their own levels of professional knowledge for teaching at a higher level. So I think we do need knowledge. It's hard to know how quite, the assessments, it's hard to know how to measure, and it's not necessarily a good thing to measure. You need standards, but how teachers deploy. I mean, some of the teachers I was trained over the years who came in from other subjects, like I remember people from geography or environmental sciences, who went on to become secondary maths teachers. They had a broader range of things to draw on, and even though they hadn't studied maths to the same high level, they'd still done some at university. As some of the pure mathematicians, it gave them a different spread, a different way of seeing, a different way of relating to mathematics. So yes, of course you need knowledge, but that it's necessary, but not sufficient to have a certain level of mathematical knowledge to be a teacher. Does that answer?
Yes. All right. Thank you so much. Those were the questions that were written on the chat box. Is there anyone in the Zoom room who would like to give their questions or comments orally to Paul? Please raise your hand. We still have a few minutes, I believe. Yeah, we have a few minutes. And
That's it. I've just seen one comment from Tap CZ, which was liked me mentioning errors and not demonizing them. And I'll just mention, as Catherine knows, that was the other talk I could have given was about errors. It's something that there's a British magazine called Mathematics Teaching. It's a journal, a professional journal for teachers. And I was asked to contribute recently. They wanted people to give one tip or one idea, just something simple. And my 2 or 3 page thing was, don't demonize errors. I think it's so important to realize that everyone has to make errors on their way to learning, and that classrooms where kids are encouraged to show their errors in public and where there's no shame, where it's it's something, it's an act of courage and participation to do that, and it helps the learning of everyone. I was privileged to be in China about 3 or 4 years ago and to see some demonstration lessons. There were some teachers, and one particular teacher was teaching a group of 39-year-olds in a big hall, and there were 20 maths education experts on each side, because this was a little bit in the middle of the hall, and then 200 maths teachers that way. And she was in this little square with a board, and this was a superb performance I saw. And even though I had to have someone translating in my ear, and the way she organized, she said it was a task about kind of sequential reasoning, and about a bus goes on and people get on and people get off, and how many, and you have to think backwards to work out how many would have got on and how many the total is, or if you know the total at the end, how many it started with if people got on and off. And she went round and selected 4 children who had different approaches to it, because they wrote their reasoning down, and got them to come up to the board one by one in order from the showing different kind of errors of reasoning in a kind of sequence that led to a better way of thinking of the problem. The children came up, they shared it, other children criticized, critiqued, discussed, and gradually progress was made. No one was diminished or felt criticized because they're and I said, this is some of the best teaching I've ever seen. This was so good, the way she used those errors as a way of getting, because we all make errors, and if you can anticipate, if you can discuss errors that are quite common, you can help people overcome them. Anyway, so I think errors are really important. We need to pay more attention to them. I think we should show children more mistaken methods of doing things and let them to identify where the errors are. I know sometimes people do that, and of course you can do that with proofs as well as calculations and all kinds of reasoning.
That was an amazing story you shared. That's really interesting, because I'm not aware of any anecdotes of such situations between teachers and students where the teacher really just allows students.
And to do that in front of 300 visitors.
Exactly.
I was
Yes,
astonished.
yes.
I couldn't do it. I would have frozen.
The shame, perhaps, that's one thing.
Just the sheer scrutiny, the judgment.
Right.
But so, yeah, errors. That was.
We have one more question, and I think this is the last that we will verbalize here. In growing importance of data science and artificial intelligence, what new ethical challenges do you see emerging in the intersection of mathematics and technology, and how can we address these challenges?
Well, I think, in a way, I hate to say it, but I think I've covered that in my views on that. That is, I think, well, people have talked about an ethical, Hippocratic oath for mathematicians, there is already, someone has published a Hippocratic oath for, what would you call them, quants, or people, or data workers. That I think it was somewhere in Sweden, they published this ethical oath that people who are applying mathematics in that kind of field, and financial or other kind of apps, I think it means the ethical problems are ever more pressing, because mathematics is underpinnings hidden behind so much of what we experience in the world today. And I think we have to start in school, and that's why I'm trying to push this and say we need to think about ethics in school and also in universities, particularly. The University of Cambridge has a project, Ethics in Mathematics, and they had some conferences, but their aim is to introduce ethics to all maths graduates that go through the University of Cambridge, and that's very interesting. You can, if anyone's interested, you can find that online. If you look up Ethics in Mathematics, Cambridge, you'll find them, and they've had 2 conferences, people speaking about that. They've developed papers. I spoke at one of those conferences, and I'm editing a book on ethics in mathematics and mathematics education, and they're represented in it. That book will come out later this year with Springer. And I'm struggling with my own chapter at the moment. And but so I think it makes the notion of ethics in mathematics all that, someone like Hardy, who was a number theorist, saying what I'm doing will never affect anyone, is not going to change the world. There's no ethical or practical significance in what I do. And as someone already said, look at cryptography, which came out of number theory, which is so important for military, for financial, for so much of data encoding. So we don't know where the applications will come, but now we know about a lot of the ones that come, a lot of the apps, and I think we just got to be very alert. And as people in education, we have a chance to reach thousands of future citizens and just give them a little twinkling of this idea, because when I was studied maths, both in university and school, the idea that maths and ethics had anything in common was, you'd have been laughed out of court. Ethics, maths, you're joking. Maths is above ethics. Maths is pure and certain and objective. But now we have to break that down and realize that serves as a cover for all sorts of stuff that's going on, and we have to alert people and prepare them to scrutinize.